We're going to look today at the last part of the syllabus, which is movement, position, distance, displacement, velocity, speed, and acceleration. Now, these are terms that we speak of all the time. What speed was he going? Yo, he's got fast acceleration. Wow, she traveled far, etc., etc. So we've got an understanding of what distance is, we've got an understanding of what speed is, and we've got an understanding of what acceleration is. We use it in everyday parlance. But in physics, okay, let me just move this out the way for this one. In physics, we need to define it. Remember, a lot of physics is about the definitions of language. Let's first of all talk about movement, shall we? Okay, I just want to go put it back onto starting position. So we say right, okay. Now, let's have a look at movement. Okay, movement. First of all, let's have a look at position. Okay, position, generally speaking, we've got an origin. Is start point, right? The origin is the point where we're starting. Now, the position can be at any point in time. So the position is after, say, 10 seconds, where are we? It just says where we are after time. And if you look at it, if you've got somebody running, after so far, they are there. And after so much more time, they're there. After so much more time, they are there. That indicates the position of where an object, a person, a car, an aeroplane is. The next thing is distance. Distance, okay? That's kilometers, meters, millimeters, etc. Okay? Generally in physics, as we've said, we all kilograms, meters, seconds. So it's meters. The distance is how far did it travel. Okay? How far did it travel? Now, let's for example say, right, let's just take an athletics track, shall we? All right. Let's just take a track like this. Okay. Not the greatest. I mean, really and truly, I could have done better, I think. Okay. Let me just try and do a little bit better than that for a track. But let's say, okay, we've got that piece, and we've got that piece, and a semicircle there, and a semicircle at that end. Okay, like that. Whoops. All right, but you guys get the drift of what I'm trying to do here. All right. Okay. Now, let's say we start at A to B, we go to C, D. Now, when we've run from A to B, all right, let's say that's 100, that's 100. Around the outside is 100, and around there is 100. Okay. Now, obviously, right, you can tell me what the diameter is if you know the circumference is 200, right? For argument's sake, let's work it out. Circumference equals pi d. Circumference is 100 and 100 is 200 is equal to pi d. Therefore, d is going to be 200 divided by pi. 200 divide shift pi equals 63.66 meters, okay? It's not critical. Okay? Now, let us say, how far have I gone when I've gone from A to B? I have gone 100 meters, haven't I? By the time I've gone to C, I have done 200 meters. At D, my distance is 300, and back to A is a distance of 400. So from A to B is a distance of 100. From A to C, 200. From A to D is going to be 300. From A back to A is 400, right? Now, so a distance, if something travels, if something does this, like that, okay, we add up the total length that it has traveled, right? That is the distance. And we measure it in meters, as we've done above, okay? Probably shouldn't have drawn that so squiggly, but whatever. Now, the next term that we have to come in contact with is displacement, okay? Now, displacement. Okay? Displacement, okay, is how far have you gone from origin? All right? So let us say, for example, I have gone this way, this way, this way, this way, this way, this way, and that way. Whoops. Let's put it back there, just like that. Okay? Now let us say that we did 10, 10, 5, 10, 5, 10, and 10. Okay? This is my origin, right? How far have I walked? 10, 10, 5. 10, 20, 30, 40, 50. I have walked a distance of, as we said, 10, 20, 30, 40, 50, 60 meters. My distance is the distance I have walked. My displacement, and this is the difference, is that. The displacement is how far from the origin. How far from the origin? There's my displacement. All right? And my displacement is 10, 20 is only displacement equals 30 meters, because that's 30. 10, 20, 30. That's how far I'm away from the origin. Let's go back to our athletics track. Okay? Now we've got distance. Let's in red put displacement, shall we? Displacement. Okay? Let's go A to B. My displacement, this is my origin. My displacement is 100 meters. Okay? Now, I've now gone to C. Where am I? I'm now over there. So this is my displacement. Okay? My displacement, can you see, is triangle 163.6. So I would use Pythagoras, right? 100 squared plus 63.66 squared equals that, all to the power of a half, equals 118.5. Right? See that? My displacement, now let's say I move from A to D. My displacement is now, how far am I from the origin? 63.66. Now I move from A to A. How far am I from the origin? My displacement is 0. Right? So the displacement, okay, is how far from the origin. But the difference is this, okay? And this is the key. A distance is a scalar. Displacement, yep, you've got it, is a vector. So when I go back up here and I go back to my displacement table, all right, I actually need to put in a direction. So that's 100. This one will be at an angle, okay? This is 60. In other words, we could have said north, south, okay? Or positive, negative. Positive, okay? Displacement is there, is a positive. Here is a negative. There is 0. Okay? Or this is east. That's going to be what? Southeast-ish. That's going to be south. And that's going to be 0. All right? Now, remember the displacement is a vector because it tells us a direction, but it tells us how far. It is magnitude and a direction. Okay? Let's look now at speed and velocity, shall we? That's also an interesting concept because you know how we often talk about, first of all, speed. What speed are we traveling? We are traveling at 90 kilometers per hour. Also written 90 kilometers HR minus 1. All right? Same thing. What do we say now? We say that's the speed, right? 90 kilometers per hour. Because it's not telling me I'm going east, north, south, west, or positive or negative, is it? So speed is a measure of distance over time. All right? It's distance divided by time. Kilometers is a measure of distance, hours a measure of time. And we always do it in meters per second, or ms minus 1. Right? So speed, it doesn't tell me am I going east or north or south or southwest. It just gives me a value. Right? It's I tell you travel at 90 kilometers an hour. Which way? Which way is the velocity. The velocity. The velocity, all right, so this is a scalar because it doesn't give me a direction. Velocity gives me magnitude plus direction because I tell you 90 kilometers per hour west, which means I go 90 kilometers per hour that way. Right? Where is this important? Well, it's important if you're flying an aeroplane. All right? Why? Well, let's say we are flying an aeroplane that way. All right? And we're flying our aeroplane at 500 kilometers per hour. Right? Now, we all know that at 30,000 feet, okay, there is wind. So, we could have a wind blowing this way at 40. Let's say we have a wind that way blowing at, I don't know, 120 kilometers per hour. Let's say, like that, right? So that's a fairly strong wind, but it's blowing that way. What's the plane going to do? The plane is flying this way, isn't it? It's going like this. But what's the wind doing? It's pushing it that way. Can you see? What are we heading for here? We're heading for, once again, resolving resultants, okay? Components. They're all going to come into this as well. But we'll get there. So this aeroplane is going to be flying, actually, it's going to be flying, where's my green? It's going to be flying that way. Because what would we do? We would put the red 120 there. And we would find the green, which is the resultant. Right? So, we've got velocity and speed. We said velocity has got a direction. They're not difficult. So anything that's got a number and a direction is a vector. So if it's distance and it's got a number and a direction, it's a vector. And it's displacement. Displacement is measured from the origin. It's a vector quantity, right? Let's continue. Okay. Then we say, okay, The next thing we're going to look at is acceleration. All right? Okay, let's go back. Acceleration. Okay, what is acceleration? Well, before we measure it, acceleration is a cheetah. We all know that that thing can accelerate from 0 to 100 in shoo, like that, right? It's one of the fastest accelerating animals. Well, I think it is the fastest. I believe it can even outdo certain vehicles and things like that. But now, it's got an acceleration. For those into cars and things, the acceleration of this is 0 to 100 in so many seconds. 0 to 200 in so many seconds. We measure the acceleration. What happens when you're in a vehicle and somebody presses the accelerator? The car starts going faster. So acceleration is we go faster. Right? Now if we go faster, what happens? Okay, let's take the car. Okay, the car over here. All right, and it's traveling this way at 60 kilometers per hour. And let's say a little bit further. Now we put our foot on the accelerator, right? And after a while, let's say the car's now over here. Okay, the car's now over there. And the car is now traveling at 90 kilometers per hour. All right. Now, from here to here, it has covered a distance. It has increased its displacement. Okay. Just think about the car. Be in the car. In this kind of physics, become one with it. Okay. Pretend you are the car. What happens? I'm traveling and all of a sudden, what has increased? My velocity has increased. So it's increased velocity. That is what acceleration is, all right? So it is increasing the velocity, okay? Now, let's just go back now and, well, no, let's do it from here, right? So the velocity is increasing. That's acceleration. Hang on. What happens if I'm stopping? I'm a car. Okay, there I am. I'm traveling this way at 60 kilometers per hour, and after a period of time, okay, I'm now stopped. My velocity has changed, and this is a displacement. Okay? This is my actual stopping distance. It's the stopping distance. If you ever watched indoor athletics when they're doing the sprints, the hall is too short for them to stop. So they run against this huge airbag at the back, or foam bag. I saw it the other day watching it, and it's, I mean, they can't stop in time, right? You're on a bicycle or a scooter or whatever. You've got to have a stopping distance, okay? Because if it isn't, you're not going to make it in time and stop, and you're going to hit something in front of you, okay? What happened here is the car, it did what? It decreased velocity. Decreased velocity. Okay, let me just make that tidy. Velocity. The velocity decreased. What does this mean? Well, let's just look at some of the numbers and things. Okay, we're going to go through a whole load of examples and things like that. Let's have a look. Okay. Yep. So let's have a look. First of all, distance and displacement. The unit of that is going to be equal to d. Here, delta x. Okay. For some of you doing O and A levels or uni, it's S. But don't worry about that too much at this stage. Sometimes you do see on your formula sheets formulas with S in it. That is displacement, right? Let's now look at speed. Okay, speed, okay, is measured as speed. Velocity is measured as V, and this is measured in meters. Velocity, meters per second. Lastly, acceleration. Acceleration is A, and it is measured meters per second squared. Okay, now just lastly, let's remember that these here are scalar and these are vector quantities. Even acceleration, of course it is. Acceleration is a vector. Let's look why. Okay, if I am going in this direction at 100 meters per second, and over here I'm going at 200 meters per second, my velocity has increased. I have accelerated to the right, okay, or positive or east early. Okay, if I'm going at 100 meters per second and over here I'm going at 50 meters per second, I have decelerated. Okay, I've had negative acceleration to the right. Essentially, we have decelerated. Okay, we've slowed down. This is slowing down. Okay, we were moving this way and now we've put an acceleration that way. Don't get too hung up on that. We're going to do some examples of it. Okay, so that's basically where we are with these now. So those are some of the terms. Scalar is just a number. Vector, number, and direction. Okay? Vectors are things like displacement, velocity, acceleration. What's the difference between distance and displacement? A lot. Displacement has got the direction into it. The distance is the total that I traveled. The displacement is measured how far from where I started. Okay? In other words, the shortest route to that point, a straight line if you think about it. Okay? Now, so it's to there, for example, right? That is the displacement. The distance can be a full athletics track, 400 meters. My displacement is 0 because actually I haven't gone anywhere in displacement terms because my vector is 0. I'm back where I started. All right? So remember, a deceleration is an acceleration in the opposite. It's a negative acceleration. Okay. Next one we're going to go into is going to be actually looking at some examples of some of these over here. Okay. We're going to do a few with a truck traveling at certain things, and then we're going to get into Newton's equations of motion. That'll be the next lot. Always remember, okay, look for a number and a direction. Cheers. See you next time.